Hello friends, welcome to HP Vibrant Academy. In the last lecture we have discussed about the representation of elements of the symmetric group. So what we have seen in the previous lecture is that the elements of symmetric group are represented either in array form or in the cycle form. So what we have seen in the last lecture is that the symmetric group is nothing but the set of bijections from a n element set to a n element set, and these bijections form a group under operation composition of function. So this A is nothing but n element set because we have a symmetric group on n letter. Okay, so this is nothing but A is nothing but a n element set 1 2 3 up to n. Okay, so these bijections are from a n element set to a n element set. These are nothing but the bijections, and bijection is also known as 1 1 onto mapping. 1 1 onto mapping. Okay, suppose we have S5. S5 is nothing but symmetric group on 5 letter. Okay, so this bijection is from 5 element set 1 2 3 to 5 4 5 5 element set to a 5 element set. Okay, so these bijections will form a group under operation composition of function, and this f is nothing but 1 1 onto mapping. Okay, so this Sn, the number of elements in this Sn will be n factorial, because Sn is a group of order n factorial. So this means n factorial number of bijections will be there. N factorial number of bijections will be there, and these bijections can be represented. These bijections can be represented either in array form or in the cycle form. Okay, so in this particular lecture we will discuss about this these bijections can be represented either in array form or in the cycle form, and these bijections are also known as permutations. Bijections are also known as permutations. Okay, so total n factorial number of permutations will be there in Sn, because Sn is a group of order n factorial, so n factorial number of permutations will be there. Okay, so in this particular lecture we will discuss about the properties of these permutations. Okay, so let us start our discussion on the properties of permutation. So this we can write as, so here in the first row we have the elements of domain, and in the second row we have elements of codomain. So here we have this, we can write as the cycle is, let us represent this in a cycle form. So here let us write down the first element. So we have first one is 1. Okay, so 1 goes to 2, 1 goes to 2. So we have now 2 goes to 1, so 2 goes to 1, so this is closed. The cycle is completed. So here 1 goes to 2 and 2 goes to 1. So 1 goes to 2 and 2 goes to 1. Now we have 3. So here 3 goes to 3, this is closed. Now we have 4 goes to 5, so this is 4 goes to 5, and we have 5 goes to 4, so this is closed. 4 goes to 5 and 5 goes to 4, this is closed. Okay, so let us read the statement. So we have every permutation can be represented as cycle or product of disjoint cycle. So this 1 2 3 and 4 5, these are nothing but disjoint cycles, as there are no elements common. So there is no element common between 1 2 and 3. Okay, so these cycles are disjoint cycle because there are no elements in common. Well, now let us write down this for the beta. Okay, here we have 1 goes to 5, so 1 goes to 5, and 5 goes to 3, 5 goes to 3. Now we have 3 goes to 1, so this is closed. 1 goes to 5, so 1 goes to 5, 5 goes to 3, and 3 goes to 1, so this is closed. So this is nothing but 3 cycle. Now we have this, let us take this 2, so this is 2. Now we have 2 goes to 4, 2 goes to 4 and 4 goes to 2, 2 goes to 4 and 4 goes to 2, this is closed. Okay, So all elements are covered, 1, 2, 3, 4 and 5. So these are nothing but disjoint cycles. Disjoint cycles. As there are no elements common in this one, these cycles 1, 5, 3 and 2, 4. ओके कोई एलिमेंट कॉमन नहीं है ना 1, 5, 3 और 2, 4 के बीच में. ओके अगर ऐसा रहता 1, 2, 3 और 1, 2 तो ये डिसजॉइंट साइकिल नहीं है बिकॉज 1 इज कॉमन हेयर. एज सिंपल एज दैट. नाउ वी हैव गामा. ओके सो लेट अस राइट डाउन दिस. सो वी हैव 1 goes to 2, 1 goes to 2, 2 goes to 3, 2 goes to 3. Now we have 3 goes to 4 and 4 goes to 5 and we have 5 goes to 1. So this is closed. This is nothing but a cycle. Okay, so let us read the statement first. So we have every permutation. So these are the permutation can be represented as a cycle. So this is cycle and or product of disjoint cycle. So these are the product of disjoint cycle, product of disjoint cycle, and this is a cycle itself. So every permutation, these are the permutation can be represented as product of disjoint cycle or as a cycle. Okay, now let us discuss the second one, disjoint cycles commute. So before proceeding further, let us discuss this one 153. Okay, suppose we have given a cycle as 153. What does it mean? अगर कोई साइकिल दिया हुआ है 153 उसका क्या मतलब है? ओके तो इसमें कैसा देखेंगे, इसमें मैक्सिमम एलिमेंट क्या है 5. तो ये कौन से सेट से आया होगा 1, 2, 3, 4, 5 5 एलिमेंट सेट से आया होगा. तो मैपिंग कहाँ से होगा 5 एलिमेंट सेट से 5 से एलिमेंट सेट में होगा. तो 1, 2, 3, 4 एंड 5, 1, 2, 3, 4 एंड 5. सो मैपिंग कहाँ से हो रहा है 5 एलिमेंट सेट से 5 एलिमेंट सेट से हो रहा है. नाउ लेट अस गो बैक टू दिस साइकिल. So this cycle means 153. This means 1 goes to 5, 5 goes to 3 and 3 goes to 1. So what about the other elements? So that is self mapping. Okay, so let us understand this. Okay, so देखो 1 कहाँ पे जा रहा है 5 पे, 1 गया जा रहा है 5 पे, तो लेके जाओ 1 जा रहा है 5 पे, 5 जा रहा है 3 पे, 5 जा रहा है 3 पे और 3 जा रहा है 1 पे. तो 3 जा रहा है 1 पे. तो बाकी का जो एलिमेंट है ना वो सेल्फ मैपिंग है. 2 goes to 2 and 4 goes to 4. So 153 को कैसे लिखेंगे? So we have the 153 as 153. This is nothing but 153. 1 goes to 5, 5 goes to 3, 3 goes to 1. And rest of the element, because this cycle has been arrived from a 5 element set 1, 2, 3, 4 and 5. समझ में आ रहा है? तो 153 कवर हो गया, 1 कवर हो गया, 5 कवर हो गया, 3 कवर हो गया, 2 और 4 बचा हुआ है. 2 goes to 2, 2 goes to 2 और 4 is also left, 4 goes to 4. तो 153 का क्या मतलब हुआ इस साइकिल का? दिस इज नथिंग बट दिस वन. So 1 goes to 5, 5 goes to 3, 3 goes to 1 and rest of the element, that's is self mapping. 2 goes to 2 and 4 goes to 4. Okay, now we have, let us proceed further. दूसरा क्या है डिसजॉइंट साइकिल कम्यूट. सो कम्यूटेटिव प्रॉपर्टी जो है ना वो डिसजॉइंट साइकिल्स पे अप्लाई होता है. तो लेट अस टेक टू साइकिल्स अल्फा एंड बीटा इज द disjoint cycle and there are the elements here is a1 a2 a3 am. Okay, and in beta we have b1 b2 b3 and bn. Okay, so if alpha beta is equal to beta alpha, if alpha and beta have no entries in common, alpha and beta have no entries in common, this means alpha and beta are disjoint cycles. So let us take the example. So we have the alpha 1 as alpha 1 is equal to 153 and alpha 2 क्या है 24. ठीक है, ठीक है. तो 153 इसका क्या मतलब है, ये साइकिल का अभी हमने बात किया. तो 153 कहाँ से आया होगा 5 एलिमेंट सेट से आया होगा. 1, 2, 3, 4 5 एलिमेंट सेट से. ओके, सो लेट अस डू द मल्टीप्लिकेशन. मल्टीप्लिकेशन कैसे करेंगे ये दिखाता हूँ मैं. तो वी हैव अल्फा 1 इज इक्वल टू 153 और अल्फा 2 इज इक्वल टू 24. So we have alpha 1 alpha 2, this is equal to, let us write down in the array form. Okay, so we have alpha 1 alpha 2 is nothing but this is equal to 153 times of 2 4. So this is equal to, so here we have 1 goes to 5. So let us write down the elements here, 1 2 3 4 and 5. So we have 1 goes to 5, 1 goes to 5, 5 goes to 3, 5 goes to 3, and 3 goes to 1, and we have 2 goes to 4, 2 goes to 4, and 4 goes to 2. Okay, now we have alpha 2 alpha 1, alpha 2 alpha 1. This is equal to 2 4 times of 153. So this is equal to, let us write down the this in array form. So we have the elements as 1 2 3 4 and 5. Okay, so now we have 1 goes to 5. So let us start from here, 2 4. So 2 goes to 4, 2 goes to 4, and 4 goes to 2, and we have 1 goes to 5, 1 goes to 5, 5 goes to 3, 5 goes to 3, and 3 goes to 1. So this is same as this one. So this means alpha 1 alpha 2 is equal to alpha 2 alpha 1. So this means disjoint cycles commute, disjoint cycles commute. Okay, so these are the disjoint cycle because there are no elements in common here. Okay, now let us discuss 3. The order of M cycle is M. Okay, so we have alpha is equal to 1 2 3. Now we have alpha square is equal to 1 2 3 times of 1 2 3. Let us do the multiplication. Okay, so multiplication start from in this particular direction. So this is equal to, let us take the first element. So this is 1. So 1 goes to 2, 1 goes to 2. Now let us, now after 1 goes to 2, now let us jump to this one, this cycle. So 2 goes to 3. From here 2 goes to 3. So 1 goes to 2 and 2 goes to 3. So this is 3. Okay, now we have 3 goes to 1. Now let us jump to first cycle. So 1 goes to 2. So 3 goes to 1 and 1 goes to 2. So this is 2. So this is closed. This is alpha square. Now we have alpha cube. Alpha cube is equal to alpha square times of alpha. So this is 1 3 2 times of 1 2 3. Okay, so let us start this. So 1 कहाँ पे जा रहा है, 2 पे. So 1 जा रहा है. Let us write down the first element. So 1 2 पे जा रहा है और 2 1 पे जा रहा है. So this is closed. Now we have second element 2 here. तो 2 कहाँ पे जा रहा है, 3 पे, और 3 कहाँ पे जा रहा है, 2 पे. सो दिस इज क्लोज्ड. नाउ वी हैव द थर्ड एलिमेंट, दिस इज 3, दिस वन इज 3. तो 3 कहाँ पे जा रहा है, 1 पे, और 1 कहाँ पे जा रहा है, 3 पे. सो दिस इज क्लोज्ड. सो दिस इज नथिंग बट आइडेंटिटी alpha cube. So this is nothing but this cycle. Let us represent this cycle. This is a 3 element set to a 3 element set, 1 2 3, because this is 1 2 3. So 1 2 3, the maximum element is 3 here. So this cycle has arisen from a 3 element set, 1 2 3. This cycle has arisen based on the mapping from 3 element set to a 3 element set. Okay, so we have 1 goes to 1, this is 1 goes to 1, this is 2 goes to 2, and this is 3. This is identity mapping. So alpha to the power cube, this means if we apply the operation composition of function on alpha 3 times, then we get the identity. This means order of alpha is equal to 3. Okay, now let us take the example of beta. बीटा क्या दिया हुआ है यहाँ पे, बीटा इज इक्वल टू 4 5. ठीक है, तो ये साइकिल कहाँ से आया होगा, दिस साइकिल हैज कम फ्रॉम ए मैपिंग, दिस साइकिल हैज कम फ्रॉम ए मैपिंग फ्रॉम ए 5 एलिमेंट सेट टू ए 5 एलिमेंट सेट, टू ए 5 एलिमेंट सेट. Okay, so now let us apply beta square. This is equal to 4 5 times of 4 5. Okay, so let us write down here. Let us take the first element, that is 5. So sorry, this is 4. So 4 goes to 5 and 5 goes to 4. So this is closed. 4 goes to 5. This is, let us take the first element here, that is 4. So 4 कहाँ पे जा रहा है, 4 5 पे जा रहा है, और 5 कहाँ पे जा रहा है, 4 पे जा रहा है. So this is closed. Now let us take this one 5. So 5 कहाँ पे जा रहा है, 4 पे, और 4 जा रहा है 5 पे. This is closed. This is nothing but identity. So beta square is equal to identity. This means we have applied the operation composition of function on beta 2 times, then we get the identity. This means order of beta is equal to 2. Okay, so we have the order of alpha as 3 and order of order of beta is 2, and alpha is 1 2 3. This means this is a 3 cycle, and beta is 4 5. This is a 2 cycle. Okay, so alpha is 3 cycle and beta is 2 cycle. Okay, so the order of alpha is this one. So this is 3 cycle. This means this is a m is equal to 3 here, and here we have m is equal to 2. So m is equal to order of alpha. So this is the statement is order of m cycle is m. So जितना cycle का this value, this is m cycle, m का जितना value है उतना ही value order का होगा. तो अल्फा का order 3 है, इसका मतलब this is a 3 cycle. अगर बीटा का order 2 है, this means that permutation is a 2 cycle. As simple as that. ठीक है. Let us discuss the fourth property. Order of permutation of a finite set written in a disjoint cycle form is LCM of length of the cycle. So we have alpha beta as alpha beta. So alpha we have 1 2 3, this is 3 cycle, and 4 5 this is beta. This is a 2 cycle. So this is nothing but 3 cycle, because the number of the terms here is 3. This is 3 cycle, and this is a 2 cycle. The order of alpha beta is equal to LCM of order of alpha and beta. Okay, so this is alpha and this is beta. Okay, so order of alpha is equal to value of m. This is 3 cycle, so alpha is equal to order of alpha will be 2. This is equal to LCM of order of alpha is order of alpha is 3, because this is a 3 cycle, and order of beta is 2 because this is a 2 cycle. So LCM of 3 and 2 is 6. So order of alpha beta is equal to 6. As simple as that. So let us show this, how we can show this. So we have alpha beta is equal to 1 2 3 times of 4 5. Okay, so we have alpha beta square, this is equal to 1 2 3 whole square times of 4 5 whole square. Okay, so we have 1 2 3 whole square. Okay, this is nothing but 1 2 3 times of 1 2 3. Let us do the multiplication. So we have 1 goes to 2. तो पहला एलिमेंट देखो यहाँ पे, फर्स्ट इज दिस 1. तो 1 कहाँ पे जा रहा है, 2 पे जा रहा है, और 2 3 पे जा रहा है. इसका मतलब 1 3 पे जा रहा है. ठीक है. नाउ लेट अस टेक दिस 1 3 कहाँ पे जा रहा है, 3 1 पे जा रहा है, और 1 2 पे जा रहा है. तो दिस इज 2. So all the elements are covered. This means 1 2 3. If the operation is applied 2 times, then this is equal to 1 3 2. Now we have 4 5. The operation is applied 2 times. This is equal to 4 5 times of 4 5. Okay, so this is nothing but, so here let us write down this. तो पहला लिखो यहाँ पे 4 5, और मल्टीप्लिकेशन कहाँ इस डायरेक्शन में होता है. सो फर्स्ट वन इज 4. So 4 goes to 5 and 5 goes to 4. This is closed. Now we have 5. So 5 goes to 4 and 4 goes to 5. This is closed. This is nothing but identity. So this is nothing but identity. And 1 2 3. 1 2 3, the operation is applied 2 times. This is nothing but 1 3 2. This is equal to 1 3 2 times of identity. 1 3 2 times of identity. Okay. Now let us apply the operation 3 times. We have alpha beta. Operation is applied 3 times. This is nothing but alpha to the power 3 and beta to the power 3. And alpha to the power 3 is equal to identity, because order of alpha is nothing but 3. है ना? Alpha to the power 3 is identity. This means order of alpha is 3. So the alpha to the power 3, this is nothing but identity. So this is equal to identity times of beta cube, and this is equal to identity times of beta square and beta. So nothing, and beta square is nothing but identity. because order of beta is 2. So identity times of identity, and this is beta. So this is equal to beta. So alpha beta to the power cube is nothing but beta. Now we have alpha beta to the power 4. This is equal to alpha beta times of cube into alpha beta. Okay, and alpha beta cube, this is nothing but beta. So this is beta times of alpha beta. This is equal to alpha beta to the power 4, and this is equal to alpha beta square. Now we have alpha beta to the power 5. This is nothing but this alpha beta to the power 4 into alpha beta. This is equal to alpha beta square into alpha beta, and this is equal to alpha square beta cube. Okay, and this is alpha beta to the power 5. This is equal to alpha square beta square into beta. Beta cube we can write as beta square into beta, and this beta square is nothing but identity. So this is equal to alpha square beta, and we have alpha beta to the power 6. This is nothing but alpha beta to the power 5 times of alpha beta, and this is equal to this one, alpha beta to the power 5. So alpha square beta into alpha beta, this is equal to alpha cube beta square, and alpha this is alpha cube nothing but identity, because the order of alpha is 3, and beta to the power 2 is nothing but identity, because order of beta is 2. This is equal to identity. So alpha beta to the power 6 is equal to identity. This means order of alpha beta is equal to 6, and this is equal to LCM of 3 comma 2, and this is equal to this we can write as alpha beta का order क्या हो जाएगा, LCM of this is 3 2, and 3 is nothing but order of alpha, and 2 is nothing but order of beta. Okay, so the order of permutation of a finite set written in disjoint cycle form is LCM of length of the cycle. ठीक है, डिसजॉइंट साइकिल है ना दोनों, ये भी डिसजॉइंट, ये दोनों क्या है, डिसजॉइंट साइकिल है, बिकॉज कोई भी एलिमेंट कॉमन नहीं है. तो अल्फा बीटा का ऑर्डर क्या हो जाएगा, दोनों का जो ऑर्डर है ना उसका एलसीएम हो जाएगा. तो एलसीएम ऑफ दिस वन, 1 2 3 का ऑर्डर क्या है, 1 2 3 का ऑर्डर है 3, और 4 5 का ऑर्डर है 2. सो एलसीएम ऑफ 3 2 इज नथिंग बट 6. सो ऑर्डर ऑफ अल्फा बीटा इज 6. ठीक है, नाउ लेट अस प्रोसीड फर्दर. Okay, so now let us discuss this fifth one. What is written here? Every permutation in Sn n greater than 1 is a product of two cycle transposition. Transposition क्या होता है? Two cycle is known as transposition. Two cycle is known as transposition. Okay, so 1 5 क्या है? Transposition है, because it is a two cycle. 1 2 3 ये transposition है क्या? नहीं है, because this is a 3 cycle. Two cycle is known as transposition. Okay, तो किसी भी साइकिल को हम ट्रांसपोजिशंस के फॉर्म में, प्रोडक्ट ऑफ ट्रांसपोजिशन के फॉर्म में लिख सकते हैं. ठीक है, तो वी हैव द बेसिक स्ट्रक्चर ऑफ दिस इज this we can write in one of the form, this we can apply this one. Okay, so 1 2 3 4 5, this is a 5 cycle, and we have broken this into 4 number of transposition using this one. Okay, so we have this as a1 a2 a3 up to am. Okay, so this we can write as this is a1 a2 a3 am minus 2 am minus 1 and am. Okay, so इसको कैसे लिखोगे? So this we can write as first one and the last element. So this is a1 am. Okay, now we have the first element and the second last element, a1 am minus 1. Now we have a1 and this one, a1 am minus 2, like this, and the last one will be a1 a2. So like this we can write. Suppose we have 1 2 3 4 5. So how we can broke this into transpositions? So we have first one and the last one. So this is 1 5, Similarly, first one in the second last one, this is 1 4. First one in the, this is third last form, so this is 1 3, and we have 1 2. So we have decomposed this into 4 number of transposition. Okay, so 1 2 3 4 5, this is nothing but a 5 cycle. 5 cycle can be decomposed into a 4 number of transposition like this. It can be decomposed into a 4 number of transposition like this. It can be decomposed into a 6 number of transposition like this. So hence we can say that the decomposition of a cycle in transposition is nothing but 2 cycle, is not unique. Okay, now we have the sixth one. If a permutation alpha is expressed like this, where beta I and gamma I are the transpositions, so then both R and S are either even or odd. Okay, तो देखो 1 3 2 1 4 3 2 एक साइकिल है. कैसा साइकिल है? 4 साइकिल है, बिकॉज 4 टर्म्स आर देयर. कितना है? 1 4 3 2. ये क्या है? दिस इज ए नथिंग बट 4 साइकिल. 4 साइकिल. तो 4 साइकिल को हम कितने नंबर ऑफ ट्रांसपोजिशन में ब्रेक कर सकते हैं? 5 में कर सकते हैं और 3 में कर सकते हैं. तो इसका क्या मतलब है ना, ये 5 और 3 है ना, ये क्या है? ऑड है. समझ में आ रहा है? तो जो साइकिल का जो डिकम्पोजिशन होगा ट्रांसपोजिशन में, वो आइदर ऑड नंबर ऑफ ट्रांसपोजिशंस होगा या फिर इवन नंबर ऑफ ट्रांसपोजिशंस होगा. तो दिस इज बेसिक द कंसेप्ट ऑफ, फ्रॉम हेयर द कंसेप्ट ऑफ इवन एंड ऑड परमुटेशंस अराइजेस. इवन एंड ऑड permutation arises. This we will discuss in next lecture. Okay, तो जो साइकिल है हमारा, तो साइकिल का जो डिकम्पोजिशन होगा, तो डिकम्पोजिशन जो होगा उसमें जो नंबर ऑफ ट्रांसपोजिशन होगा ना, वो आइदर इवन होगा या ऑड होगा. तो यहाँ पे क्या है? ये 4 साइकिल है, तो इसका जो डिकम्पोजिशन हो रहा है ये 5 नंबर ऑफ ट्रांसपोजिशन में हो रहा है या फिर 3 नंबर में हो रहा है. तो 5 और 3 क्या है? ऑड है. तो जो डिकम्पोजिशन जो होगा वो आइदर इवन में होगा या फिर ऑड में होगा, है ना. तो यहाँ 5 और 3 दोनों ऑड है ना. अब देखो इसमें क्या है, ये क्या है? 3 साइकिल है. तो इसका डिकम्पोजिशन किस में हो रहा है? इवन में हो रहा है ना. 2 इवन है और 2 भी इवन है. ओके, सो आइदर इवन में डिकम्पोजिशन होगा या इवन नंबर ऑफ ट्रांसपोजिशन में होगा या फिर ऑड नंबर ऑफ ट्रांसपोजिशन होगा. एज सिंपल एज दैट. ठीक है, वी विल डिस्कस फर्दर इन नेक्स्ट पर्टिकुलर लेक्चर. थैंक यू.